Assalamu alaikum, everybody. This is Abdul Fattah, and today we are going to talk about directional derivatives. In particular, today we will see uh, the second order uh, directional derivatives. So we have typed it into LaTeX, and we will be looking at the things in LaTeX format. Because right now we are not having those facilities to write with some writing pad. So today we will be talking on this particular format. So let's consider a function that is taking my input from R2 and it is throwing it into R. So we have a scalar function from R2 to R. What we have to do is we have to drive the formula for its second order directional derivatives, and in the particular direction vector a comma b, that is a general basically unit vector. So let's see. uh, we know that first order directional derivative in the direction of this unit vector is given by, how is it given by, let's see. uh, yes. So what we do for the first order directional derivative, let's say. So what we do basically, we do nothing. We calculate the gradient of f and we take its dot product with the given direction vector, that is a unit vector. And you know that the gradient is computed by partial of f with respect to x and partial of f with respect to y. And then you have to take its dot product with a comma b. So when you will take this dot product, then by inner product in particular, dot product I'm saying, so inner product is a dot product. So there isn't different at this stage. So we have taken the dot product of these two vectors, this vector and this vector, and it gives me this. So this is nothing but first order directional derivatives of f in the direction of a comma b. But what uh, we are interested in the second order directional derivatives. So let's see how we have to do. Let me bring some worked out things in front of you. Yeah, so there we go. Let's see what comes. Yeah. So let's see what comes. Sometimes we have some technical issues. Okay, so yeah, so we are interested in the second order directional derivatives. We all know that the first order directional derivative was this. To compute second order directional derivatives, we need to take the directional derivative of first directional derivative. So whatever we have calculated is the first order directional derivative, and this, and now we will take its the first order directional derivative, so that it will be the second order directional derivative of the original function f. What we have to do, we have to do nothing. In fact, we have to do something. Let me not say nothing. So what we have to do? We have to take the gradient vector of this function now, because previously we had f. Now we have the first directional derivative of f. So we will take its gradient and take its dot product with the same unit vector u. So this first order directional derivative, as computed before, is given by this thing, and we have to take its dot product with this guy, this unit vector. And what we do when we take the gradient of any function, we do nothing. We make a vector where we take the partial derivative of the function with respect to x, this over here, and partial derivative of the function with respect to y. So when you simplify, we will simplify later. Uh, so, so here I have put this plus. It's a typo. It should have been, it shouldn't have been this plus. It should have been comma, because it's a vector. So when you simplify this dot product, you will get when you simplify this dot product, you will get this thing. And further, when you will differentiate this thing with respect to x and this thing with respect to y, you will be left with what? Let's see what we are left with. So let's see. We are going to be left with, let's see what we are left with. Let's see what we are left with. So yeah, let me remove these all my crazy drawings. Okay, so what we are left with? Let's see what we are left with. Yeah, so we are left with, we have got something very simple and in fact very nice. What I did, so I have represented this partial derivative of f, second partial derivative of f with respect to x, like fxx, and the partial derivative of fy with respect to fx. So this is fyx. This is nothing but partial derivative with respect to y, and then with respect to x. This is nothing but partial derivative of f with respect to x and then y. And then we have partial derivative of f with respect to y and then y. So second partial derivative of f with respect to y. So this is nothing but simplification of this over here. So when you will simplify this and then further simplify algebraically, you will get, it's nothing but a simple algebra and you will get this. So this is the required form. This is the required form, the required formula that we had to drive for second order directional derivative of function f in the direction of a unit vector. That was a general unit vector, say a, b. And then interestingly, so you can notice one thing, that whatever guy this is, you can write it in this form, like this form. So where a comma b is a unit vector, that is a directional vector. So if it is in the column form or it is in the vector form, so column vector are row vector. So it's nothing but that particular thing, and then we have this. So what is this now? So I have put this second order directional derivative in this matrix notation, where this matrix is interesting, because this is what we are going to see, that is, this is very interesting matrix. Why this is very interesting matrix? Let's look at that. So that's what, let's see, that's what, why that's interesting. So I have got this. Let me remove this crazy drawing. So yeah, okay. So why this is interesting? Basically, it is interesting because this j, which is applied on f of x comma y, is nothing but Jacobian of the gradient of f. So second order directional derivative can be put it into the form of, uh, what we say, Jacobian of this gradient of f. So this is the form that we needed. So let me say this was the formula that we had to try, and these two are very interesting forms of the second order directional derivatives that we can always write the second order directional derivatives in. So in the next few lectures, inshallah, we will be more generalizing it. So we will be taking now third order directional derivative, then fourth, fifth, and so on and so forth. And then at the end, what we will do, we will be generalizing this function f. Now f is from R2 to R, and in the next lecture you will see that this will be moving from this is fr2 to R, and then we will make it rn to R, and then rn to R, and so on and so forth. Inshallah, we will be continuing. So for now, thank you very much. Thank you very much. So this is what we required. So these are the results. These are the things that we needed to try. Thank you so much.